Hi, so here we're going to look at the intersection of two lines in the 3D plane, 3D space. So if we've got two lines, L1 and L2, they are going to intersect at a point, which we're then going to be able to calculate and find. But also if we wanted to find the angle at the intersection, they are going to calculate, they're going to meet at a certain angle. But what is easier is if we know the normals to the vectors, the lines L1 and L2, then we will be able to just calculate the angle between two normals, as that will be equal to the angle between the two lines. And you need to be careful about whether it's asking for the acute or the obtuse angle. And then if you don't recognise that, it'll be easy to know which one you've got. So, first thing I'm going to do for example 1, which is just calculating the angle, is state the normals, and then I will be able to calculate the angle using what we know from higher. So remember, when it's the symmetric form in L1, the normal vector, is the denominators of the fractions, whereas if it is the parametric form, the normal is the coefficients of the parameters. Okay, so I'll have a go at this. So, I've got the normals of 1, -2, -1, and the normals of -1, 1, 0. And then I got the scalar product, which was -3, and then I got the magnitudes of root 6 and root 2, put them onto my formula, and got that to be 150 degrees. Now, knowing that it's an acute angle, all I need to do to get the acute angle was take 150 away from 180. Okay. If it had come out as 30 and you asked to find the obtuse angle, you'd have just done the exact same thing. So, looking at example 2, prove that these two lines, x minus 5 over 1 equals y plus 2 over -1 equals z, and x minus 12 over 5 equals y plus 3 over -2 equals z minus 5 over 4, intersect, and hence state the point of intersection. So we don't know that they intersect right now, so our method is going to be expressing them in their parametric forms, and then I'm going to create a system of equations which I can solve by simultaneous equations, and if I get a consistent answer, that must mean that they intersect. Okay? And then from that, I'll be able to state the point of intersection. So what I've just done is I had equated the x equations from L1 and L2, and the y equations from L1 and L2, solved them simultaneously for the values of s equal to -2 and t equals to -3. Now, if I substitute these in to the z equations and get the same answers for z in both L1 and L2, then that means they must intersect. So there, I've got a consistent value for z at -3, and therefore the lines intersect. And now all I need to do to calculate the point of intersection is now calculate what x is and what y is. And it doesn't matter which ones you use, as we know it's correct. So they're giving me my values of 2, 1, and -3. And that is the intersection of two lines.